animal tracking device, composed of an Arduino Uno and 6 attached sensors. The GPS module will track the global positions of the zebra to understand its migration patterns. The pulse oximeter vital sensor will track the vitals of the zebra, such as its oxygen percentage and heart rate, to ensure it is alive and in healthy conditions. The LDR sensor will distinguish if it is daytime or nighttime. The ultrasonic sensor will detect other zebras, predators, and obstacles in front of the zebra. The temperature sensor will determine how hot or cold it is. The humidity sensor, or DHT, will detect how much humidity there is in the air. It is important to measure environmental characteristics to make observations on how climate conditions affect the migration patterns, vital health, and daily movement of zebras. The sensors will be connected to the Arduino via wires, and ideally, I would place this device in waterproof cases that can also protect it from earth elements such as debris. I would make this device 3 to 5 pounds so that it is not heavy and does not interfere with the zebra's mobility. My program starts by including libraries for the Adafruit GPS sensor, the pulse oximeter sensor, and the DHT sensor. These libraries allow me to instantiate an object for each of these 3 modules, which will be used throughout my code. I also defined some variables for the LDR, ultrasonic, and temperature sensors. These variables include the pins and the values that they will be measuring. An Arduino program has 2 main methods, the setup method and the loop method. The setup method only executes exactly 1 time. In my setup method, I wrote code to initiate my sensors, and I did this by using functions such as pin mode and digital write. The pin mode function allows me to declare inputs and outputs for my sensors. So here, sensors are attached to specific pins, and I have to specify them, which ones I will use. And that is why I made it simpler for me to define the pins as such in the beginning. After I specified all the pin inputs and outputs for my sensors and my networking, I wrote the serial begin line, and I also allowed the humidity sensor to begin as well. The loop method runs infinitely over and over again until the program stops. In my loop method, I initiated some string variables that will contain the data collected by the sensors. This section allows the vitals sensor to collect oxygen levels and heart rate data from the animal it is tracking. As you can see in my device topology, this LED light is connected to the Arduino and the resistor, and then this resistor is connected to the LED light and the Arduino. This is how these 3 components are working. When my vital sensor begins to take data, it prompts pin 3 to start working. After pin 3 has an electric charge, then it will travel through this wire, and then the resistor will reduce the current flow, and it will reach the LED light, and the LED light will turn on. Otherwise, when my vital sensor is not collecting data, pin 3 is on low, and the LED light cannot turn on. Alright, this section, my humidity sensor is collecting data and converting it into a percentage. And here the LDR sensor is collecting the data, and the ultrasonic sensor is collecting the data here, and then my temperature sensor is collecting the data. To set up the networking, I created a new project called Network Receiver. The network receiver consists of 1 Arduino Uno. In my setup method, I serial begin, and my loop method states that if the available messages are not equal to 0, meaning that there is at least 1 message or more, then that message will be read and will be stored in this received message variable. Now I will print this string stored in the received message variable, and it will be specified by data received from sender, and then you will see that data that this Arduino is receiving from another Arduino. And then I will delay. I'm going to test my network receiver by placing it next to my animal tracking device. I walked you through the code for the network receiver. Now I want to walk you through the code for the network sender. So here I have this message that I want this Arduino to send the other Arduino. And here you can see data, and it has a GPS message, the vitals message, the LDR message, the ultrasonic sensor message, the temperature message, and the humidity message. And then my Arduino will send this message, and this is a variable with the data. And I'll send it through pin 0, which was specified here. And a very important thing about my code here is that at the end of my Arduino program, I write this delayed 2000 so that all the sensors and the hardware can normalize and get ready for the next sensor read. I'm going to click save and submit. And now the simulation has started. Here you can see in the simulation log that all my sensors were successfully validated, and here you can see information from the temperature sensor, the humidity sensor, ultrasonic sensor, the Arduino, the pulse oximeter, the resistor, the GPS, this, and then the LED light. This helps with debugging. You can see the information, the data gathered by all these sensors. Now let's look at the serial monitor. Here you see the serial begin message that printed in the setup. And so this is confirming that the setup is done, and now everything is beginning. This is the first time that the first Arduino starts collecting data. Some of the data isn't available the first time around. Let's look at the second time that the first Arduino starts collecting data. You have the GPS coordinates, you have the oxygen percentage level, the humidity level, the light level, the distance of the nearby front obstacle, the temperature, and this is a string of data that will be sent to the second Arduino. And you can see all that data is in here in this string. And now, remember how here it says data received from sender? I'm going to try to find that data received from sender, and here you can see that the second Arduino successfully received the data from my first Arduino because it's printing the GPS coordinates data, the oxygen percentage data, the heart rate, light level, distance of the nearby front obstacle, the temperature, the humidity, all the data is in there. So my networking is successful. I successfully tested my network receiver, so I can delete it now. I ended up renaming my device to the Wildlife Animal Tracking Device to give it a more straightforward and simple name. And my device is now ready to be deployed. To deploy my device, I am going to sign in to World. I'm going to copy this code, launch my IoT Virtual Worlds game, start, enter the code, and log in. Right, I am going to press M to look at the map, and I'm going to click where I want to teleport. I'm going to find some zebras to attach my device to. They run very fast. Now I'm going to attach these devices to some lions. Please work, please work. Why doesn't this? Oh, it's working, it's working. Okay, I just needed to give it a little bit of time. Awesome. And here you see all the data logs. And now let's try to find an elephant. Here you are. That ring around the animal means that it has my device attached. I managed to get my device on all of the animals. When I get close to one of the animals with my device attached, you can see all the data here. And this ID is elephant 744 AFA. And here I can take a close look at all the data printed. Now, here you can see the data, you can see the GPS coordinates, the oxygen percentage, heart rate, light level, the distance of the nearby front obstacle, temperature, humidity. Everything is there. Okay, this is the same elephant. And I want to add the network receiver to the elephant. And although we can't see anything here because there are some issues with the software, you can see it in the data log that this software returns after I exit the game. Now, given that the network receiver works, it should receive this data string that you see here with all the data information that the device is collecting. Alright, and here is a list of animals, and I'm clicking on all of them, and you can see that the animals all have devices. I am going to now exit. Now I am going to go to the Savannah logs folder, and this is a session that I just ended. And this is the data from the simulation. This is the data that my animal tracking device has collected on the animals that they were attached to. Now, here you can see that different elephants all have their unique data. I also collected data from zebras. And finally, I collected data from lions. Let's look at this elephant. The heart rate is very low because elephants walk very slowly since they're bigger animals. So this makes sense. The heart rate is at 45, and it's pretty constant because elephants in this virtual savanna don't really run. Let's look at the data collected from this specific zebra. There are timestamps, and then there's data. So this data was collected throughout time, and here you can see the temperature, the humidity, distance, oxygen saturation, light, and location. Now here, this is from the moment that I attached the device. So the zebra was just walking very slowly at the moment. And then as you continue to see the heart rate and the oxygen saturation, you can tell that the vitals change once the zebra starts running. Alright, so the zebra walks, it stops, and then it just zooms. This is the point where the zebra starts running, and their heart rate goes up to 200, and their oxygen saturation drops to 0.96. And the zebra continues running. You can also see that the location is changing here at much faster intervals. And then at this point, the zebra just stops running, and then continues running again. Now let's look at the lion. Let's look at the specific lion. When it's walking slowly, the heart rate is at 90, the oxygen saturation is 98%, and it's walking very slowly. And at this point, the lion stops walking and just zooms, it just runs. And heart rate goes increasingly high up to 160, and the oxygen saturation drops 96%. And you can see that it keeps on running. And it runs for a very long time. So far, it looks like all my animals are pretty healthy. They have a healthy heart rate and healthy oxygen levels, and they can walk normal distances, and it looks like they're all doing well.